The next part to make, I'm going to make the ferrule. Goes onto the end of the cable like that. The handle goes through there. The handle's on a cam, it's eccentric. You pull that and it tightens the cable. That's what locks the device up. So I'm going to be on the collar chuck. I'll take my 3-jaw chuck off. Once again, bed protector. Make sure the threads on the end are clean. The compress there. The collar holder. I'll just put a few drops of oil on it. On the end. Just ordinary engine oil, look after it. That register there is really important. Any bits of dirt in there in your chuck constantly go through. Spin lock on the lathe. Nip it up with a round bowl fountain to make the ferrule out. Oh, I'm not sure what it is. It's shiny and fairly hard. Once we get into machining this, you'll see how versatile these collets are, because we can go straight from here into the milling machine. See, it's running nice and true. It's one thing about the collets, I can take that bar out of there and put it back in again, and it'll be running true within a few tenths of a thou. First thing I want to do is machine the end square. That's left no pip because the tool is dead on centre height. Next thing we need to do, reduce its diameter. Its diameter is actually, it's 430. I did a drawing, I've got a drawing on the board, 430. My piece of board, I think it's 1/2 inch. 600. So I want 170 thou of it. Put some power feed on. I bought a new lamp. On Saturday I went to IKEA with the missus. She was looking at curtains and I got my eye on these. A flexible lamp, £10, low voltage, has a little transformer with it. It comes with a metal base, but it only held on with 2 screws. I mounted it onto a little bracket there. Much better than the lamp I used to use. I used to stand down here and magnetic used to get covered in swarf. We'll see how that goes, but I think I'll be buying some more of them. For £10 you can't go wrong. I put a bit of tape around there to make it waterproof. It's got an LED in it, so it should last a long time. Like I say, for £10 you can't go wrong. On 430 we're actually at 450. 5 thou cut. Putting a reasonable finish on. That's the size I want, spot on. Put a chamfer on the end of it. Something that looks better means you wouldn't cut your fingers as well. Simple drill. Finished part 750 long, so if I drill an inch, a hole an inch deep, I'll know I'll have enough. Just keep it lubricated. It's a brand new drill this, it's one of my number drills, I don't want to break it. Just going off the graduations on the tailstock. Get me depth of hole. As long as it's deep enough. As long as it's deeper than the finished job. Right, that's an inch. We've got an inch of hole. It's more than enough. We'll put the drill back straight away. Right, it needs a counter bore in the end. 1/4 inch counter bore, but I'm going to use a milling cutter so I get a nice square end and a nice square edge on the hole. The depth of the hole is important. It needs to be 600 thou. So the way I do it, I've got my milling cutter tightened up in there. The graduations on the tailstock are not accurate enough. Fetch that up to touches, lock the tailstock up. Then what I do, I'll put a tool in there, I'll wind that back till it's touching, tighten it up, carriage back until that's touching the edge of the chuck, lock the carriage off. The compound slide, take up the backlash and set it to 0. Zero there. Wind it in, 600 thou. 1, 2, 3, 4, 5, 600. Right, if I drill me hole, when I wind, everything's locked up. When I wind my tailstock in, once it hits on there, I know I'm 600 thou deep. I'll measure it. If I can get my clamp in. Dead on 600 thou. So I know I drill the hole until the chuck hits that tool, that milling cutter's end's gone in 600 thou. Touching there, you can't go any deeper, you can't go wrong. And take the cutter out the chuck and put it away. You don't leave cutters like that in the chuck, them edges are sharp and cut your hands to bits. Plus being a carbide mill, you've only got to bang it and it'll shatter. Carbide mills like to shatter, it's one of the favourite pastimes. Right, so now we're down to diameter, we've got a hole through for our cable, we've got a counter bore in for our ferrule to the right depth. I'll measure it. .600 thou, or as near as, makes no difference. Right, and I've got a face mounted. We've got what ER32 collar holder, square one this time. Into the face with it. Gentle bed down with the rubber hammer. Right, we need to find the centre of that. Use a wiggler. Nice starret one that I got given. That one there. You can use a chuck for doing this. Chuck runs pretty true on this machine. We're setting up so it's nipping it. When you set it away, there's a great temptation to try and square it with your fingers. Don't do it, it hurts. Set it away, some metal. See when it's right, it'll stop moving altogether. Like that, not moving. Right, so what we'll do, make sure it's set on centre height. You advance the work in towards it, and as soon as it touches, you'll see it push it off line. That's the edge there. Stop the machine. You can see the y-axis on the DRO. That ball is touching the very edge of that workpiece. Right, half the thickness of the ball is 125, which is one full turn on this machine, which is there, which is 125 thou on my DRO. Scale on here is exactly the same as the DRO, strangely enough. Right, we need to know the thickness of the piece we're working on. I can't remember what it was now. Let's see with that again. 220. Right, it is dead to centre, so what I've done, I've zeroed the y-axis and I've also locked it off. What we want now, we want to find the end of the bar. Watch for it moving. That's the end of the bar. Zero the x-axis, straight away I can come in 125 thou, which is there. Check that out. Right, the centre of the hole I want is 300 from the end. So we've already moved in 125, that puts on the edge. We'll zero that again. 300, 1, 2, 300. Lock the x-axis off. Got a centre drill in there. Looks like it's going to hit in the middle. Got the right size drill. I'll feed this in using the using the table feed. Tends to grab if you use it like a pillar drill. Nice and gently. Right, now we need a slot machining up there. What you don't do, it's very tempting, put the cutter in there and use the drill chuck. Don't, then I like it enough that you don't get a good enough hole, you'll break the cutter, you'll mess the job up. For what it takes to change it to a collet, it's seconds really. Right, so we've got that collet in, cutter. Everything's still locked up on the centre of that hole. So we'll loosen off our table clamp. I've speeded it up. You've got to run carbide tool and fast, very fast. That's better. That cutter's ambition in life is to break. Right, so we can take the job back out of there now. Back to our lathe. Right, the parting tool is level with the end of the job. It's on centre height. Carriage is locked. We want 750 thou, which is 1, 2, 3, 4, 5, 6, 700 and 20, 30, 40, 50 thou. Right, so we'll start the way. Reasonable speed. Stop and break the cutter. Keep weighing it in. Something to catch it with. Right, I've turned it round. Actually put a smaller collet in to hold it. All I want now is the end squaring up and a nice little chamfer putting on. I can find the friggin' tool, there it is. Once again, right hand knife tool. .45° tool, just put a little chamfer on it. Finishing it off. good. Right, I've cleaned it up a little bit with a needle file and try it on. Spot on. See, that goes on there. And that's your cam. That's the bit we'll be making next. That'll be a bit more interesting. Anyway, thanks for watching.